Hi, today we're going to talk about graphing. Now you might be saying, graphing. That sounds a lot like geometry, but we're doing Algebra 1. What on earth does geometry have to do with algebra? Well, the truth is, absolutely everything. Because today we're going to be introducing a tool that's going to expand and really dominate every single topic that we're going to talk about from now on. And that is graphing using the Cartesian coordinate system. You might say, Cartesian coordinate? What on earth is that? I've never heard of that. Well, let's start slowly. Now, when you were in elementary school, you probably had the number line, right? You had all the numbers on the number line from 0 to 1, and 2, and 3, and then once you learned negative numbers, it was -1, -2, -3. Right? This is our number line. Well, Cartesian coordinates are exactly like this. Except instead of having one number line, they have a horizontal number line and a vertical number line. So not only do we have from negative infinity to positive infinity along here, we have the same thing going up here. Right? So we essentially have two number lines working in tandem. And we call this Cartesian coordinates. You might say, how on earth am I supposed to track which points are where? Right? If I have a point here, how do I know what that point is? At least if I have a single number line and that dot's on 2, I say, well, I know I have 2. But here, my dot's just not on 2, it's also on 1. What do we do? Well, and here's where your algebra senses might start tingling. We distinguish the two number lines. We call this number line x, our horizontal component. We call this number line y, our vertical, or up and down coordinate. And we express every point on this graph, this coordinate plane, in terms of x and y. So this point here, well, we have a 2 at x and a 1 at y. So this coordinate point here, we would write as, we always use parentheses, 2, 1. What about this point here? Well, we're -3 at x, and we're -5 at y. So this point is -3, -5. What about here? Well, here, both x and y are 0. So we call this point 0, 0. Now, we call this point by another name, and that's the origin. Because both graphs, both lines, our x and our y, meet at 0, 0. So we can call it the origin. Let's do some more practice. What's this point here? Well, we have a 2 at x and a -2 at y. So this point here is 2, -2. Now you might say, well, this is all fun and games, and we can plot points all we want, but that's still geometry. Where on earth are we going to get to algebra? Why do I need to care about all this stuff at all? Well, here's where the magic is going to happen. In previous lessons, we've been doing a lot with algebraic equations, right? And we've slowly gotten to the point where we have algebraic equations with both an x and a y, with two different types of variables. Let's say we have something like this: y equals x. Just this. We don't have a system where we're trying to find the values of x and y. We just have this single equation. What can we do with this? Well, when we graph it, we get something very, very interesting. Well, now, you might be saying, well, how on earth do I graph it on this coordinate plane? Let's think about it this way. If I plug in 1 for x, I get 1 for y. So I can put my dot here. If I plug in 0 for x, I get 0 for y. So I'm going to put my dot here. And if I keep doing this, 2, 2, I notice that all my dots start to form a pattern. And if I were to do all the spaces in between the dots, I'd find that they also would form a pattern. We would get a line. We would get a line that goes on for infinity, all from this algebraic equation. And we can create this line by using our y and our x axes. Right? I plug in 1 for x and I get 1 for y. So I put that point 1, 1 on my graph. I plug in 2 for x and I get 2 for y. So I plug in the point 2, 2 on my graph. And I can keep going on and on and on in both directions, and I can get a single line. Now, this is the magic of algebra. We call this type of thing analytic geometry. What does that mean? Well, we're dealing plainly with geometry. This is, after all, a line. But we're getting all this from an algebraic equation. And so we're taking what we've been doing in algebra and applying it to geometry. And we're getting something brand new and really, really cool. And you might say, well, we can create other lines too. And you're right, we can. In the following lessons, we're going to explore how to graph the lines produced by all the equations we've been learning how to solve, and explore what more we can do with this interesting field. So stick around. I hope this video excited you, and I hope this video helped, and I hope you have a great day.